D-Lab, and on the bench today I have a Magnatone little combo amp that was shipped to me for repair. This amp has already been to another shop. They condemned the power transformer. Symptoms are the amp is dead. Let's see if that guy was right. Let's put her on the bench. Let's go. So here's a little classic Magnatone. This is the first one like this that I've ever run across. It's very cool. I love the cabinet. It looks pretty much complete, pretty original. Let's pop this cover off and take a look at the chassis. Alright, back cover is removed. Taking a look, it has the original speaker. And it looks to be in great condition. I don't see any rips. Looks like the original power transformer. It's got a 6SJ7 preamp, 6V6 output, 5Y3 rectifier. Volume pot there is missing the knob. There's your input jacks. Idiot light fuse holder. And there is the model number. So next thing I want to do is bring this thing up on a Variac and see if there's any life at all. So anytime I have an amp come in here that's dead, the first thing I do is hook it up to a Variac. In this case we'll take her at about 50 volts. Then I'm going to go over here and monitor the current. Okay, so obviously there's no current right now because the amp's not on, right? Go over here, flip on the power switch. No indications of life yet. Let's take a look at the current meter. As you can see, we have 0 current. Now I was told that the fuse has already been checked, so I'm not going to bother with that right now. I'm just going to pull the chassis and let's see what's going on underneath, and hopefully it's not that power transformer. So I pulled out the chassis, and you can see back here, oops, there's a little woolly booger living in there. We'll get him out later. Anyway, here we are. Let's check out bottom side. You can see she looks pretty much original. There's a volume pot with the AC switch, filter caps, there's that fuse holder. So what I'm going to do next is just hook up an ohm meter across the AC line cord and let's see if we have any resistance at all. Alright, my trusty Beckman set at 0 to 200 ohms is right across the AC line cord prongs, and that volume switch is still in the on position. We have an open circuit. Alright, so you naturally assume maybe it's that fuse, right? But since it's been checked, I'm not going to re-verify, but the next thing I'm going to do is throw a jumper wire across the switch on the back of the volume pot and see if that primary resistance shows up on the meter. Alright, so here we go. Pop on my little jumper wire here. Take a look at our meter. I'm still, whoop, look at there. Had some bad connections on the AC prongs, but look, 19 ohms of resistance. So guess what? I think we got us an open switch. So let's move our multimeter across the switch terminals. Looky there. Let's try the switch. There it is, people. Defective AC switch. So now I'm going to put my jumper back across it and let's see if the amp comes to life. Alright, so I've got the AC switch jumped. My meter is monitoring the high voltage coming off the filter cap. Turn on my Variac. Got 50 volts applied. Look at there. Here comes the high voltage. She's ramping up. Look at there. The light's on. So guess what? The amp is springing to life. Now I highly doubt that it's going to work properly, but at least we know the power transformer is good. And the reason I have it on the Variac is if that filter cap is leaky, I don't want to damage the amp any further. But at this point, it appears as though it's going to be a fairly simple repair. Now that we've determined that the amp will actually power up, what I want to do is give it a quick wellness check. So I have an audio generator set up over there, injecting about 500-600 hertz tone. I'm going to bring the power up slowly to the amp with the signal applied, and let's see if it can produce any audio. Because if it can, that would indicate all we really need to do at this point would be change out some capacitors, maybe check the tubes, etc. But this will tell me if the output section is even working. So I'm up around 75 volts. Hear what I hear? She is alive, but there is hum. Hear it? So at this point I'm going to kill it and put in some fresh filter caps, check the resistoroids, etc. But it looks like the little Magnatone is going to live on here very soon. So pretty amazing, isn't it? This old Magnatone still wants to operate, even though it's in severe hurting status from wear and tear over the years, but it still wants to deliver that music. And that's because this is good old American point-to-point wire technology, something we're never going to see again, unfortunately. But here's a plan of action. You see these old paper caps? This one down here is actually bubbling. He's in pretty bad shape. They all got to come out because they're known to leak. There's no reason to leave those in there. The main filter cap is obviously bad, and even though it looks like a newer style cap, it is the original. The solder connections down here on the terminals have never been interrupted, so that's pretty amazing. There's another cap up here. It looks pretty nasty. So obviously I'm changing out all the electrolytics, the coupling caps, then I'll check the resistors, see if they're way out of tolerance. These are old 10% value type. There's our output transformer tucked up there. There is a little bit of mold on the wires, a little bit of corrosion on the chassis, but all in all, this thing's in great shape for its age. So I'll start first with changing out the volume control switched pot. This is a 500K pot. I've got a really nice alpha unit that'll drop right in there. It has the same 3/8 inch shaft that this one does. So we'll get that changed, and then we'll change the caps. And I'm going to bring this thing up on the Variac again, but this time we'll hook up a scope and see what the sine wave's looking like, and take this one step at a time. So the new alpha pot's installed, and as you can see, the AC line coming in, this wire's in really bad shape. Somebody's been in here with some electrical tape. She's pretty crunchy and rotted, so I'm going to change that out later. So for right now, I just have that tack soldered on to the power terminal. Next thing, let's get these caps changed, and then we'll bring it up and see if we've made any improvements. For the capacitors, I'll start out first with the main filter cap. And you can see this band. This band goes around the cap, and down underneath here where you can't see, it's actually soldered to one of the lugs that support the power transformer. So a lot of guys get in here and they reef on these things back and forth and try to fatigue the metal. I don't go through all that. I just grab my trusty Dremel tool and cut that band. Then the cap will pop right out. The cap is loose. What's the value? Looks like a dual 16 at 450 volts. So here's that band I was telling you about that supported the old original filter cap. It's soldered to one of the screws that hold the power transformer to the chassis. So I'm going to remove all that. I'm going to add a terminal board to the back wall here, mount our new filter caps on it, and wire them back in where the old one was. So this other large cap soldered to the back of the chassis actually goes, if you follow this wire, to pin 8 of the 6V6. So that's just the cathode cap. I'm not going to change it out with some big honker like this. I'm going to put a new technology one right from pin 8 to pin 1, because 1 is going to ground. So that will free up some of the footprint in this amp. So on the back wall, I'm going to mount this terminal board, and then a pair of these nice 22 microfarad 500 volt F&T caps. So I've got the new terminal board in place to ensure good grounds. I've got my old Unger iron here, good old 1000-degree monster. Solder those terminals right to the chassis to ensure we get a super good ground. We'll have to worry about mechanical integrity of screws, which can loosen over time and give you problems with your amps. So I always solder these. Out with the old, in with the new. Is there new caps in there? New filter caps mounted up. I left the death cap in there for now until I change the power cord, but I think it's a good time to fire it up and see if we've made any headway on this thing. Alright, so here we go, initial test. Got the audio generator as our input. My scope is monitoring right across the speaker output. We're on the Variac. Got 50 volts over there. We're going to let her warm up, and then we'll watch the current. Make sure nothing goes crazy on us. Got a power light on. Everything's looking good. I'm going to jack her up to like 75 volts. Okay. Oh, here comes the old tone. Let's look at the scope. So she's looking good. I'm going to go ahead and give her full power here. Here we go. Full power. Plug her in. Take a look at that plate voltage. Settles down to about 250 volts. Everything looks a-okay. So my next step is to check the tubes and buzz out the resistors. But I think the Magnatone is very close. Tubes all checked good, believe it or not. The only other thing I found that was out of tolerance was this 10K resistor, which is an old unbanded type, it's the 20%er. It actually measured 12K. And that was on the old filter cap that was all hummy and leaky, so I thought better change that out. So it is in place right there. The amp is pretty well complete. I have to change the AC line cord, get rid of the death cap. I did buzz out the primary to make sure there's no leakage to ground off the power transformer, so it is safe to put a 3-prong cord on this amp. That'd be my next step. Well, I'd call that a magnificent repair. Here's the bago parts. There's the amp on, humming away. Very little hum, that's good, right? And what is inside of the amp? Could it be? Why, yes. My reward. Hope you enjoyed the video. We'll see you again. Terry here at D-Lab.